Welcome back. We are continuing with chapter 3, and we're going to talk about graphs of functions, and we're going to jump right into it. Determine whether the graph is that of a function, and the way we're going to do that is what's called the vertical line test. If it is, and even if it's not, we can use the graph to find the domain, range, intercepts, symmetry, and so on. So in this case, we would do the vertical line test, and we can see if I do a vertical line, let's use this here, you can see that it's touching in two places. Therefore, it's not a function. Every vertical line can only cross the graph one time if it's to be a function. And that's due to the definition of what a function is. We can still find the domain and range. The domain in this case is from -2 to 2. Remember, those are x values only. And we are including the endpoints. The range goes from -3 to +3, inclusive. Intercepts, so x-intercepts, we can see it crosses at the point -2, 0, and the point 2, 0. Y-intercepts, we're crossing at 0, -3, and 0, 3. And it is symmetric to both the x and y axis. Axis, IS is singular, ES is plural. All right, that was A. That's supposed to be A, it's supposed to be for that one there. B is here. And here we have a graph. And there's actually something here called an vertical asymptote. Meaning the graph is going to get closer and closer, but never actually touch it. And this does pass the vertical line test. You can see every vertical line is going to cross this graph one time. Never more than once, not like this one up here. So this is a function. And we will learn how to graph these functions by the end of the semester. All right, the domain. In this case, it looks like it is bigger than 2, and note it will never touch 2. And it's going to go off to infinity in the x direction. The y direction, the range. It looks like it's going to go from -infinity to +infinity. So this is going to get bigger and bigger and bigger. Looks like we have an x-intercept at 3, 0. And just based on what we see, there's no y-intercept. Right, this isn't going to cross this line here, so it's never going to hit here. And for this one, there is no symmetry. Right. Here we have a nice straight line. And they want to know the coordinates of the x-intercept is. X-intercept is back here. That's going to be -2, 0. The y-intercept, that is 0, 2. And what type of symmetry? No symmetry. And let me quickly demonstrate for you the symmetry. What I mean by the symmetry is if I cut that in half, the other half of this should be a mirror image, and it is. Same here. The bottom half should be a mirror image, and it is. All right. Example 3. Find the domain and range. All right. So for the domain, those are x values. So again, even though it's down here, I don't care up or down, I'm left and right only. So this is going to go from -3 including -3, solid dot, all the way over to x equals 1, but because it's an open circle, it doesn't cover it. It's not included. The range, now we are only looking at y values. We're going to start down here at -5, including -5, solid dot. We're going to go all the way up to 4, including 4. Now, I do want to point out, it kind of feels like I should be using 3 somehow, but you can see 3 is defined on this graph over here. So 3 is included, even though the endpoint here is not included. All right, for example, 4, we don't have a graph, but we're going to answer these questions anyway. Let's start with part A. The point 3, 6, is it on the graph F? Let's see. So y is 6. 2 times 3 over, and x is 3, 3 minus 2. This gives me 6 over 1 equals 6. Indeed it is. So yes, the point 3, 6 is on F. Part B. For x equals -2, what is f of x? So f of -2 is 2 times -2 over -2 minus 2, -4 over -4. Looks to me we are at 1. Meaning the point -2, 1 is on that graph. Part C. If f of x is 3, what is x? So now we're going the other way. So if this equals 3, we have 2x over x minus 2. So now I have an equation I have to solve for. So I'm going to go ahead and multiply through by the LCD in this case, which is x minus 2. Distribute the 3, 3x minus 6 equals 2x. And if I add the 6 over and subtract the 2x over, I get x equals 6. All right, part D. Let's go over here. D. What is the domain of f? The only place we have a problem is when the denominator equals 0. So x cannot equal 2. If x equals 2, I'm dividing by 0. So the way we write that in interval notation is we go -infinity to 2, union with 2 off to infinity. This is the domain. In part E, list any zeros of f. Zeros meaning when y or f of x equals 0. So we have 0 equals 2x over x minus 2. Multiplying through by the LCD again. Of course, anything times 0 is 0. I'm going to go this way. So I get 0 equals 2x. Looks like x equals 0. So it looks like the point 0, 0 is on this here. Not too bad. One of the easier sections, I think.